Hello everyone and welcome here on the 23rd video tutorial. My name is Paul, and if you are new here, please subscribe to my channel right now and give like if you will see the video interesting. Today I will talk about the proof function. It is part of display section that I described in the tutorial number 21, and it is also second tool of the analyzer. Before I start, let me jump into the user guide as usual and see what it says. So we will go directly to the functions, and here under analyzer is the proof tool description, and proof tool is trying to prove or disprove the wave-like theory during the generation, or find the best conditions in which the theory is valid or working well. There can be later on better tools considering more conditions and parameters, but at this moment this is the best what we have, so let me explain it right now step by step. At first we have here the control panel where we can switch on and off the online monitoring of the proof tool. Then there is the activation of the proof tool, which we should do during the primary settings because after that it's not accessible. Then we can switch on and off the computation during the generation, and finally we can print out the results during the generation. And it is useful when we want to keep the generation fast and disabling the proof online monitoring, so we can from time to time to print the result. Finally, the results are printed at the end of the generation automatically. And let me explain now the basic principle. So for the proof computation we are using only all the previous existing draws, and especially we are using the number of hits from all these previous draws. So we are not using any numbers from the future predictions or from the predictions for P1 to Pn, I mean the upcoming predictions after the first future prediction. And at first it is that we go one step backward to the last drawing day where we have the number of hits, and this number of hits we are comparing with the average of all hits from the all previous draws except the last one. So in this case we are calculating the average where it's 1 plus 4 divided by 2 draws, so divided by 2 is 2.5. It is the average of the hits from the previous draws except the last one, and then we are comparing that with the result in the last one. So we are calculating the deviation, which is equal to the last hit minus the average of the previous draws. So it's D is equal H minus A. In our case is 1 minus 2.5 is equal minus 1.5. So based on the situation we can get positive deviations that has tendency to prove the theory, or the negative that has tendency to disprove the theory. And we rather to see the positive deviations, but in some cases the negative ones has also tendency to prove the theory, but let me describe this later on. Then based on the deviations and according to the level that is based on the average, I will explain later as well, we are calculating the average deviation. And this average deviation, if the computation is enabled, is printed into the output box of the result that is printed. It can be printed also in the monitor output box because it is calculated all the time. And in the level, based on the average we have that is rounded to the level, for example we have 2.5 is coming to the level number 2, we have relevant average deviation. And this I will explain in the proof box that is marked by P, and it will be visible only when you activate the proof calculation during the primary setting by this checkbox. So at first on the vertical line we have number of levels starting from 0 to maximum amount of hits. In our case, maximum amount of hits is 3 plus 2 is equal to 5, so we have 6 levels. Then for each level we have the average deviation for the positive ones and the negative ones. Then there is a number of results with the positive deviation and number of results with the negative deviation. The same is recalculated because the sum or the number of all results is equal to 100%, so then the same thing is recalculated to the percentage view, that we can see that for example 13,000 is about 56% of all printed results, or I mean not printed only but also all the calculated results, or to understand it better, it means all results that went through the filter or the gene was able to come until the end of the output box before coming back. And in case of filter, sometimes the gene is going back before it passes the previous draws, so then it's not considered as a result and it's not calculated. So I repeat it again, not only printed results but all the results are considered in this computation in case the proof function is, the calculation is on during the generation. And then finally we have the sum of deviations we are getting during the generation from all the results with the positive trend, and also sum of deviations with the negative results for every level we were able to reach during the generation. For example, we got maximum into the level number 3 in this case. And now I will explain how to read the results you will obtain. You can have the weak scenario. It means that when we have the horizontal line that represents the number of previous draws from 1 to n plus the last draw, and here, as I explained before, we are calculating the average, and if the average is low and then the deviation can be close to 0 but negative, or equal to 0 or close to 0 but positive, then we can say it has still tendency to disprove the theory. But if the deviation is far or very far from 0, then we can say that it has tendency to prove the theory. That's the weak scenario. Then we have the moderate scenario, where the average of the all previous draws except the last one is in some middle value, for example equal to 3 or 4. Then the interpretation of result is a little bit different and more positive for us. So we can disprove the theory only in case the deviation is negative and it is far from 0. If it's little bit below 0 or close to 0 or above 0 from far from 0, it has still the tendency to prove the theory, because when we are below 0 or equal to 0, we have still some prediction. Imagine that the average is equal to 4 and then we are close to 0 and negative. We have, for example, 3 predictions or 3 numbers, then it is still good probability to win some prize, and it is something that is worth it for us. Finally, we have the strong scenario. It is that it can happen when we have the high average of the previous draws except the last one. In that case, if the deviation is very far from 0, I mean it's close to the absolute 0 or far from 0, then we can say that we can disprove the theory. But in case is equal to 0 or close or not so far from 0, it means we have, if you have, for example, number of hits equal the average equal to 6, and then the deviation is, for example, 1 or 2, dropping 2 values down, 2 levels down, we have still 4 predictions. So in this case we have still good predictions, and we can say that we are proving the theory here. As I said before, we are using still the all known data of the previous draw and last draw. So based on this, we already know the upcoming drawing day, which is the last one. So we went in the time one step backward. Finally, I need to point out the correct filter settings, and the best one for using the proof function is to leave the filter setting empty without any walls. So it is the optimal situation. You can have the walls here as you wish, but you should keep the last one empty, and I will explain why. So if you put here some wall into the last cell or column, then you will have wrong result, and that will be distorted and not relevant to reality. Also, this scenario is not the good one because it will distort the results as well. So the last position for the proof function you should keep empty, like we have here or here. And let's imagine what can happen here. If we have, for example, low scenario, it means the average is very small, and then you should get at least 5 hits to get over the wall to consider the result into computation or the result to be printed. So it means what will happen is this scenario or this one. So you will have the low average or the middle average, but you won't be able to get any negative or deviation close to 0, or you will not be able to get such a situation that is disproving the theory, because these results will not be passing the filter and will not be passing through the whole loop, so they will not be considered in the calculation, and you will get only results with this situation. And it can mislead you that you can think the theory is proved, but in fact the values were distorted because these bad ones were excluded completely. So keep it in mind, and if you want to analyze the results in the proof function and the values, use the filter settings like this one or something like this one, keeping the last one empty. This can be different than on this picture. So that's all what the user guide says about the proof function. And now let me jump into the gene directly and see how it works. So during the primary settings, we should activate by this checkbox the proof function. So now it's disabled, and after the primary settings you will not be able to activate it. So you should activate it like this. Then we will select for today Fantasy 5, and I will print the output boxes. So there is the filter box, input box, and also the proof box, like you saw in the user guide, will be printed right here. If it will be disabled, then it will be without this proof box, so no computation will be available here. So it's up to you how you will decide. And in advance I prepared the numbers of this Fantasy 5 lottery, the last drawings. And now I can start the generation. Right now we have this online monitoring on, so the computed values are updated during the generation all the time. We got to the level number 2. We have here these positive average deviations for each level, negative ones, and we have also the number of results with the positive deviations, number of results with the negative deviations for each level. The same thing is recalculated to the percentage. For example, we have 20% of negative deviations in the second level, and now it changed. Finally, there is a sum of deviations for each level of the positive deviations and sum of deviations in the negative or with the negative values. So the average is calculated that it is the sum divided by number of results. For example, 5 divided by 13 is 0.38. And that's how it works. It's simple. You can also see that the deviation, the negative or positive, is, I will pause it, is printed right here. Let's see, this one is 2 plus 1 is 3 divided by 2 is 1.5, rounded is level number 1, and it went down, so we got 1.5 minus, we got the negative deviation, so we should look here, and here is -1. So that's how we get the value right here, and this value is at every printed output box. For example, in the best one we have here the average is 2, and 2 minus 2 is 0, so we got the deviation equal to 0. But we already in the level 2 we have already more results, so when it was printed after 4 seconds as one of the best results, after time the positive deviation was changed to this value. So later on this scenario will have the different value right here. So I can continue. So I can switch off the online monitoring, and when I need, I can update the values right here. So it's computed and keeping fast the gene. We can have it switch off and just from time to time to update the values, and at the end of the generation it will be updated completely. So you don't need to do it actually. One thing what I will do is I can switch it off and continue, and as I activate the online monitoring, you see you have here the off sign, that it means the proof computation is disabled for now. So some results, if it's disabled and best result is printed, then you can end up with the off mark here. Also when it's off and I click the print, the last one was printed, but when I click it again, it's not changed right now. Then also what you can see here, the sum of percentages is always equal to 100% here. So when I make it on, it's still keeping 100%. So you can see the relative amount towards each other deviation, that for example we have the most deviations are from a 0 level and are positive. That is also positive for the proof of the wave-like theory right here, because it has still tendency to grow up. And we have 15% in the first level and 12% here on the second level. Here is 1% of the positive. So it really can help us and show, if we look for the result and seeing what is also the deviation, if it's positive or negative, it can help us decide which result we will select for our ticket. Now let me jump to the nodes, or I will switch off the online monitoring, and now let me run it with higher speed. We will see the maximum one what we will get today. It's -1. Now, yeah, we have about more than 15,000 cycles per second. It is pretty good speed. Now we reach the 16,000 cycles per second. We're just about to see if we got to the higher level as well. And now we got 3 results with negative deviation in the third level, and so it's dropping down somewhere here, not fully to the 0, but somewhere here, and the sum is equal to A. So you can see also each result has different deviation according to the level and time it was printed. So when I ended up, you see we got the last values during the generation. So that's all for today, and that's all what I wanted to say about the proof function. And thank you for watching and your attention. If you missed something, just replay it. If you are new here, please subscribe to my channel right now. Provide your feedback, comments, and I'll be glad for every like I will get from you. Join us on the Facebook page and groups. Follow the links in the description, and see you on the next video tutorials and upcoming new live streams. So stay tuned and have a good time.